Hey everyone, welcome to part 2 of the 2022 SHSAT practice test. So we're going to be starting on question number 63, so let's get started. Okay, so we have a set of possible values of m being 5, 7, and 9, and we want to know what the set is of possible values of k if 2k is equal to m plus 3. Okay, so I guess what we can do is so we know that m is either 5 or 7 or 9. So I'm going to take each of these values for m and sort of plug it into this equation and then solve for the corresponding value of k. So we're going to start with m is equal to 5. So in that case we would have 2k is equal to 5 plus 3. And therefore k would be equal to 8 divided by 2, which is 4. So this is our first case. Now if m is equal to 7, then we would have 2k is equal to 5 plus 7. And therefore k would be equal to 12 divided by 2, which is 6. And then in our final case, we would have where m is equal to 9. Then we would have 2k is equal to 9 plus 3, right, m plus 3. And therefore k would be equal to, hang on one sec. Sorry, I said 5 plus 7 here, but it would actually be 5 plus, it would be, so m plus 3, where m is equal to 7. So it would be 7 plus 3, and therefore k would be equal to 5 in this case. Okay, so now back to our final case when m is equal to 9. We have 2k is equal to 9 plus 3, so therefore k is equal to 6, right? We're solving for k. So in our first case, we had k is equal to 4, second k is equal to 5, third k is equal to 6. So therefore, the set of possible values for k is going to be 4, 5, 6. And that would be answer choice B. Okay. So let's look at problem number 64 next. So we have sort of this algebraic expression, and notably we have some things in parentheses. So the first thing that I'm going to do here is, if we look actually at the order of operations, we sort of evaluate this, right, because plus and minus have equal precedence. So we're going to evaluate sort of this plus first, because we go left to right, and this sort of comes first. So let's actually do that. So we have 7 plus 3n plus 6. So that would be 13 plus 3n. 13 plus 3n, right? And we had minus here, some other expression. So now let's actually pull in that other expression. So it was minus 4n plus 8. So now we need to distribute this negative sign. So we have 13 plus 3n, and then it would be minus 4n minus 8. Sorry about that, that was just an alarm. So we're distributing this minus sign, right, to each term. And now what we're going to do is we're going to combine like terms. So we have 3n minus 4n is negative n, and then 13 minus 8 is going to be plus 5. So if we look at the answer choices here, we see that the constant term, right, it comes first. So let's use I think it's the distributive property, or it might not be that, but anyway, this is equivalent to 5 minus n, right? We're just rearranging the terms. Okay, so that would be E. Okay, so now 65. So in a certain school, course grades range from 0 to 100, Adriana took 4 courses and her mean course grade was 90. Roberto took 5 courses. If both students have the same sum of course grades, what was Roberto's mean? Okay, so let's first find Adriana's sum, or let's find the sum of basically both students' grades. Okay, so if Adriana's mean course grade was 90, then we know that the sum of the grades must have been 90 times 4, right? Because if you think about it, mean is just the sum of the grades divided by a number of courses, right? This is what it means to be like the mean. So we're just taking this value basically and multiplying it by the number of courses to get the sum. So anyway, the sum is 90 times 4, which is 360. So that's the sum of Adriana's grades, and we're told that both students have the same sum of course grades. So this is also Roberto's sum. And now to find Roberto's average, it would just be equal to the sum of his grades over number of classes. So the sum, like we said, is 360. The number of classes that he took was 5, right? We're told that in the question. So then the average would be 5 divided by 360. This is just, let's see. This would just be 72, which is A. Right, and this makes a lot of sense because if Roberto took 5 courses and his grades sum up to the same as Adriana's, who took 4 courses, then Roberto must have scored less in each of his classes, right? Because he's taking more classes, yet his scores sum up to the same thing. So it must be 72 in this case. All right, let's go on to question 66. Okay, so on to question 66. Jenny starts a game with twice as many marbles as Kaiko. Jenny gives Kaiko 5 marbles, but she still has 10 more than Kaiko. How many marbles did Jenny have to start with? Okay, so basically Jenny at the start of the game has more marbles than Kaiko, and then, Kieko, and then Jenny gives Kieko some marbles, and so let's actually write these both as a system of equations. So at the start of the game, basically Jenny's number of marbles will be J, and Kieko's number of marbles will be K. So Jenny has twice the number of marbles as Kieko at the start of the game. And then Jenny gives Kieko 5 marbles, so she's left with J minus 5 marbles. But we're told that Jenny still has 10 more than Kieko. So if now Kieko started with K marbles, but she got 5 from Jenny. So she now has K plus 5 marbles, but that's still, but Jenny with J minus 5 marbles still has 10 more than Kieko has, right? So plus 10. Right, so I'm just putting the equations together. And so we want to know how many marbles now did Jenny have to start with. So Jenny had J marbles to start with, so we're going to solve for J. So let's take this second equation and let's simplify it. So J minus 5 on the left hand side, and then we have K plus 15 on the right hand side. And I'm going to solve for k. I'm going to solve for k here and then plug it in here. But it doesn't really matter how you do it, right? You have a system of two equations. So I'm going to subtract 15 here and 15 here. So basically we are left with k is equal to j minus 20. Okay. And now I'm going to take this equation. And so we have j is equal to 2k, but instead of k, I'm going to use this. So j minus 20. Let me clear up some space. Okay. So now j is equal to, now I'm going to distribute this 2j minus 40. And now we can subtract j from both sides. So 0 is equal to j minus 40, or j is equal to 40. Okay, and so we know that Jenny must have had 40 marbles to start with, right? And you can check this by plugging it into the equations and seeing if it works. Okay, so now on to 67. So in a scale diagram, 0.125 inches represents 125 feet, and we want to know how many inches represent 1 foot. So this looks like a proportion question. So we have 0.125 inches is equivalent to 125 feet, and we want to know how many inches represents 1 foot. So we're going to cross multiply and solve for that question mark. So 0.125 times 1 is just 0.125, and then we have to divide by that 125. Oh, and just so you know, like, right, the units are going to work out to inches, right, because we're solving for that question mark. So anyway, we have 0.125 divided by 125. So basically, we can multiply both sides by 8 in this case, right? And if we do that, well, you could solve this using like division or whatever, but this is sort of a shortcut. So 0.125 times 8 is going to be 1, and then 125 times 8 is 1,000. So 1 over 1,000 is the same thing as 0.001. So that would be answer choice A. Okay, so now 68. So we have people per vehicle at a checkpoint. So basically 40% of vehicles only had one person in them, 35% had two people in them, etc. So we're told that a researcher records the number of people in each vehicle that pass through a checkpoint, and the table above shows the percent distribution for the 420 vehicles that passed through. How many of these 420 vehicles contained at least 3 people? Okay, so if we look at least 3 people, that means 3 or more basically. So we're looking at the bottom half of this table. So we can add up the percents of people, right? So 15% had 3, 7% had 4, and 3% had 5 or more. So that this means that 25% of vehicles had at least 3 people in them. And we want to know, we don't want to know the percent, we want to know how many people that actually corresponds to. So if there were 420 vehicles, then we're going to multiply that by 25%, because we want to know 25% of 420 is equal to what? And we know that 25% or 0.25, it can also be expressed as 1 over 4. And so now we can do 420 divided by 4, which is just 105. and that would be G. Okay. So now 69. So in the pyramid above, each triangular face has the same area, right? So this pyramid basically has 4 triangular faces. So this is 1, and then this would be 2, and this would be 3, and then finally this would be 4, right? Okay, so each of those have the same area, and the base MNPQ is a square that measures 8 centimeters on each side. So therefore, this is like 8, 8, 8, and 8. If the length of RS is 6 centimeters, so RS is, this is our RS. So we're told that this is 6. What is the surface area of the pyramid excluding the base? Okay, so we want to know the surface area of the pyramid excluding the base. Okay, so let me solve this because this might be a little confusing. So what we found out is that, right, this square base has a side length of 8, and then each of the rectangles have a height. This height is 6, right? And we want to know the surface area of the pyramid excluding the base. So this basically means the area of the triangles, right? The area of the 4 triangles. So basically, if we can find, so let's write this down. The surface area is equal to 4 times the area of any of these 4 triangles. So we can say of R QP, right? Because all the triangles are going to have the same area due to the fact that, right, each side is of length 8. So let's now focus on finding the area of RQP. So we know that the height of this triangle is 6. We know that the base is 8. So therefore, we can solve for the area of RQP. Right, it's just 1/2 base times height. So that would be 1/2, and then the base we said is 8, right? It's right here. The height is going to be 6. So then this would be 24. And therefore, the surface area excluding the base would be 4 times 24 because there are 4 triangles, which would be 96. So that would be the answer. Okay. And then number 70, the perimeter of a rectangle is 510 centimeters. The ratio of the length to the width is 3:2. Okay, so we might have a rectangle like this, right? So its length is going to be slightly longer than its width. Its ratio is 3:2. What are the dimensions of this rectangle? Right, so we basically want to know what the length is and what the width is. So if, let's say that I call, right, so let's use this like 3:2. So I can say that the length is equal to 3x and the width is 2x, right? Because then the ratio of the length to the width is going to be 3x over 2x, which is equivalent to that 3:2 ratio, right? So x is some arbitrary number that we have to solve for. So then if the length is 3x, then this length here is 3x and this is 2x. And now we can actually solve for the, so we know that the perimeter of the rectangle is 510. So the perimeter is going to be 3x plus 2x plus 3x plus 2x, right? I'm just adding up the length and width 2 times. This is equal to 510. So now if we look at our left-hand side, the coefficient of the x added up would be 10. Okay, and then x would be 51. So we want to know the dimensions now, so let me clear up some space. Okay, so basically, let's first solve for the length. So the length is 3x, and this is 3 times, we solved for x, we know that that's 51. So that would be 153. Okay, and then our width would be 2 times x. So that's 2 times 51, which is 102 centimeters. So therefore our dimensions of the rectangle would be 153 length and 102 width. So that would be F. And so that'll be it for this video. In the next video we'll continue on question 71. See you then.